Solve this equation, x squared, minus y squared all squared, minus 23y, equals 8. Where x and y are integers. This is a Diophantine equation. There are two variables in one equation. How to solve this equation? Usually there are different ways to solve this kind of equations. For example, one way might be to convert the equation to the product of two algebraic expressions of variables of interest equals a number. Due to the variables of interest are integers, so each algebraic expression is an integer factor of the number. This leads to a system of equations. Then solve the system of equations, and find the integer solutions of the original equation. Another way might be to divide the problem into different cases, and narrow down the possible ranges of variables of interest. Then find the integer solutions for each case. For the given equation, it seems not easy to convert the equation to the product of two algebraic expressions of x and y, equals a number. So we will divide the problem into different cases, and narrow down the possible ranges of x and y. By rearranging the equation, we have 23y plus 8 equals x squared minus y squared all squared, which is greater than or equal to 0. So 23y must be greater than or equal to negative 8. That is, y is greater than or equal to negative 8 over 23. Therefore, y must be greater than or equal to 0. Now we divide the problem into two cases, either x is greater than or equal to 0, or x is less than 0. Case 1, x is greater than or equal to 0. The equation can be written as x squared minus y squared all squared equals 23y plus 8. As x squared minus y squared is equal to x minus y times x plus y. So the equation can be written as x minus y all squared times x plus y all squared equals 23y plus 8. This implies that x plus y all squared must divide 23y plus 8. Therefore, x plus y all squared must be less than or equal to 23y plus 8. X plus y all squared equals x squared plus 2xy plus y squared. Rearrange the inequality, we have y squared minus 23y minus 8 is less than or equal to negative x squared minus 2xy. As both x and y are greater than or equal to 0. So negative x squared minus 2xy must be less than or equal to 0. So y squared minus 23y minus 8 is less than or equal to 0. From this inequality, we can determine the possible range of y. To find the possible range of y, we consider equation y squared minus 23y minus 8 equals 0. This is a quadratic equation, so we can work out y by using the quadratic formula. Y equals negative b plus or minus root of b squared minus 4ac over 2a, where a equals 1, b equals negative 23, and c equals negative 8. So we can now write equals 23 plus or minus root of negative 23 all squared minus 4 times 1 times negative 8 over 2. Negative 23 all squared minus 4 times 1 times negative 8 equals 529 plus 32, which is equal to 561. So the equation has two roots, 23 minus root of 561 over 2 and 23 plus root of 561 over 2. For inequality 1 holding true, y must be greater than or equal to 23 minus root of 561 over 2 and less than or equal to 23 plus root of 561 over 2. As root of 561 is greater than 23 and is less than 24. So y is greater than or equal to 0 and is less than or equal to 23. Now we have narrowed down the possible range of y. For each value of y, we can find x from the original equation. Rearrange the original equation, we have x squared minus y squared all squared equals 23y, plus 8. So x squared, minus y squared, equals plus or minus root of 23y, plus 8. Therefore, x squared, equals y squared, plus or minus root of 23y, plus 8. Substitute each value of y satisfying inequalities 2, in equation 3, we can work out x squared. As both x and y are integers, so 23y plus 8, must be a perfect square. It is not difficult to check that 23y plus 8 is a perfect square, only when y equals 4 or 7. It's 100, and 169, respectively. When y equals 4, x squared equals 4 squared, plus or minus root 100, which is equal to 16, plus or minus 10. So x squared either equals 6, or 26. As none of these is a perfect square, so there are no integer solutions. So discarded. When y equals 7, x squared equals 7 squared, plus or minus root 169, which is equal to 49, plus or minus 13. So x squared either equals 36, or 62. 62 is not a perfect square. So x squared equals 36. So x equals plus or minus 6. As we assumed that x is greater than or equal to 0. So x equals 6. Therefore, xy equals 6 7. Case 2, x is less than 0. We let z equal negative x. So z is greater than 0. Now substitute x equals negative z, in the original equation, we have, negative z all squared, minus y squared all squared, minus 23y, equals 8. Negative z all squared, just equals z squared. So we can now write, z squared, minus y squared all squared, minus 23y, equals 8. This is exactly the same as the original equation, except that x is replaced by z. So from case 1, we know this equation has a solution, zy equals 6 7. As x equals negative z. Therefore, xy equal negative 6 7. So the original equation has two sets of solutions. 6 7, and negative 6 7.